in this warm-up, I'm trying to go over and review with students so they have a strong foundation for using the formulas of basic shapes. And one that I wasn't sure of that they knew was an equilateral triangle, of how much they have dealt with equilateral triangles, if any. And so we have equal sides of a triangle, and it's equilateral, means they're equal in length. The angles are also equal, which we call equiangular. They're all 60 degrees, which add up to 180 degrees. But basically, from the given information, we can see that each side of that triangle is 6 feet. So 6, 6, and 6. Well, on an equilateral triangle, you can draw a median from the vertex to the opposite side, which means that the midpoint, which makes this little segment equal to that segment on the base, so that's 3 and 3. And then I have two right triangles, and I can apply Pythagorean theorem to try to find that height or that altitude. So if I apply it to one of the triangles, 3 squared plus h squared equals 6 squared, then I have h squared equals 36 minus 9, h squared equals 27, and then if you take the square root, the height or the altitude is approximately equal to 5.2, or 3 square root of 3 if you give an exact answer. Now, I have introduced the 45, 45, 90 degree triangle this year, but 30, 60, 90 is a special right triangle that I have not introduced, that Common Core has brought down into Algebra 1, even though it used to be used only in geometry. So I am going to go ahead and introduce that a little bit this year. So if you're going to, this would have been, when we split that triangle in half, basically we had a 30 degree angle at the top, we had a 60 degree angle here. Opposite the 30 degree angle we had a side length of 3, and then opposite the 60 we had a side length of h that we didn't know, and then we knew the hypotenuse was 6. Well, the way the 30, 60, 90 degree triangle works is that everything's based off of the shortest side, which is opposite the 30 degree angle. So I'm going to call that 1, and the formula shows that opposite the 60 degree angle, how you get from the shortest side to the side opposite the 60 degree angle, which is the medium length, would be 1 times square root of 3, which is square root of 3. So you basically just multiply times square root of 3 to get from the shortest side to the medium side. Then the hypotenuse, of course, is the longest side, and you still base it off of the shortest side. You multiply 1 times 2 to get to the hypotenuse, which is going to equal 2. To get back to another side that's missing, if you're not given the shortest side, you divide by 2 to get back to 1, or divide by square root of 3 to get back to 1, and then multiply to get to the other one. So let me demonstrate it with the problem that we just had. So we knew the information that I have drawn here in this other triangle, and so I have the shortest side length. I have 3 across from the 30 degree angle. Well, how do I get from the shortest side to the medium side that's opposite the 60 degree angle? You multiply times square root of 3. So the height is actually going to equal 3 times the square root of 3, and then 3 times 2, like we said, to get to the hypotenuse is already given. It was already 6. And 3 square root of 3 is the same height. It's going to be approximately 5.2. And then there's another formula that I try to introduce to them a little bit. I go through and derive it at another time when we have more time, and I want them to get started on the renovation for the park activity. But I also tell them that there's another formula for area of an equilateral triangle, which is side squared times square root of 3 over 4, but I don't really introduce that until the end of the activity if there's time, because I don't want them using the equilateral, just the formula. I want them to be able to derive it. I'd rather see them draw the median and split the equilateral triangle in half and apply Pythagorean theorem and things they know, so that they are problem solving more in depth than just evaluating a formula.